My greetings here from the SEAM studio. Yes, this is where we take the initiative for flight safety. And in the next series, I would like to take hindsight and turn it into foresight. This will be focused on flying techniques. Why did it wrong? How can we avoid it in future? So, let's rock and roll. Let's have a look at the background. Now remember, in this case, it is not important for me all the other stuff that's going around the accident, but just look at the basic elements in this accident. First of all, it was during forward flight of between 30 and 40 knots. Quite a bit forward speed there. And then it comes full application of the left yaw pedal. Wow. In other words, what we are saying is that pilot was flying forward 30 to 40 knots and then put full left yaw. And we'll see what the effect was of exactly this input. They reckon that they were around about 300 feet above the ground. That is probably right. I don't know. Normally, game pilots don't fly 300 feet above the ground when they do maneuvers. So take it a little pinch of salt. However, 300 feet above the ground, if you do such a maneuver, is still a dangerous one. And this is interesting. The pilot did not attempt to recover from the ensuing spiral descent. I think he was mesmerized by what was busy happening. And interestingly enough, on the ground, it was found that the throttle was completely closed off. In other words, this was an R44, throttle completely closed off. And that's how they found it. Quite interesting, to say the least. Right here then, just one or two photographs, and noteworthy here. Let me just get a highlighter here, and I need the highlighter in a different color. Just look at the interesting fact here about the tail rotor. It's very, very seldom that you will see this in an accident. An accident of low RPM when the helicopter hits the ground normally leads to no or very little damage. And in this case, you can see both the tail rotor blades, they actually broke off. Now, obviously, with the full left yaw pedal in, they were at their maximum positions, angle of attack, and hitting the ground. And in the right-hand side, you can see here, on the tail, let me just get it a bit bigger for you. You'll see there on the tail that it is bent that way. In other words, there was a momentous term. There was a turning to the left, or then let's call it a spiral or quite a rotation to the left. Further noteworthy is that the helicopter blade must have taken a lot of impact, and you can also see that there's parts of the blades missing, which means in very normal terms that the blades was under power. In other words, there was something driving them. It's not like they had an engine cut or anything. So this accident was the pure result of the maneuver that the pilot tried. So let's just go through the maneuver. What he did was flying forward, and he decided this was a good game pilot operation. 30 to 40 knots, kicked in left yaw pedal very hard. This is what happens. Remember, immediately a roll starts, the near nose starts pushing down, and then they entered what they call it a spin, but this is like a spiral drive from which they did not recover and then hit the ground in that way. So now let's carry on with the basic aerodynamics. Just one or two things. Remember, in straight and level, lift equals weight, and there's no pitching moment. But look here, when the bank is increased, the lift vector tilts, and we'll get to that a little bit later on well, I'll show you a little bit more in graphical form, but the resulting is a pitch down moment, and it must be countered by a back pressure. In other words, wait, let's just see. Once we start flying, let's say it's just a normal, just to say for a normal turn. Turning is when we roll into a certain amount of degrees, then we stop the roll. Okay, that's just the helicopter blade that is trying to get to me. And then you've got to pitch her around. But now in this case, like in an aircraft, yaw into roll, and if you don't stop the yaw, you don't stop the roll. The lift vector is now seriously tilted from the vertical, and therefore there will be a nose pitching down. So it's yaw, roll, pitch down. And this is in a continual fashion. All right. Here we go. The tail rotor in forward flight is normally used to balance the helicopter. So remember, it's only the tail rotor manipulation through yaw pedals in the hover results in a hover turn. And it's stationary. Remember that in a hover turn, when you put in the yaw pedal, it's fine. It hovers around the mast and it maintains a position here. That's the whole idea of a hover turn. All right. Now, a pedal input to any side in forward flight, and let me get this red pen here, more than is required for the balance. This is where we have the problem. It'll result in a yaw with a secondary effect, a roll to the same side. As we continue with the basic aerodynamics, an excessive yaw moment in a climb, a descent or in straight level will result in the roll moment. I also say, notice that turning a helicopter or aircraft do not matter. For that matter, do not roll during the turn. A turn is a pitching moment, and I've just shown that a while ago. Okay, a roll increases the bank angle, and as such the left vector becomes more tilted, resulting in a pitch down moment. This is very basic aerodynamics, and it's the same for a fixed wing, same for a helicopter here. Maybe a little bit more tricky here and there, but the basic principle stays exactly the same. And then the more harsh the yaw maneuver, that's an important one, the more the resultant roll increase and consequently the increased pitch down moment. So this is very much like a self-fulfilling prophecy. As you fly, if the yaw is radically kept and there, or kept in all the time, the aircraft will yaw, it will roll, and it will pitch down at the same time. And those are the basic ones that we find for a spiral dive. So the question then is, can we go for a spiral dive sort of possibility? The question really is, in the case it's a fixed wing aircraft, has the further effects of excessive yaw resulting into a spiral dive. Now, the answer is that in a fixed wing, the helicopter, as such as a fixed wing, the helicopter also ends up in a spiral dive when excessive yaw is maintained. You can call it what you like, but you can call it but it's a spiral descent. It's exactly the same thing that happens to you. And the symptoms of a spiral dive is ever increasing roll rate, an increasing pitch down moment, the airspeed is increased, and as a result of your input, there is also, and notice this, unbalanced flight. How do we recover from this? Well, first of all, let's have a look at the fixed wing. And I just happen to bring a fixed wing along, so let's do this one with a fixed wing here. All right. In a fixed wing, what we do is, if we want to yaw to the left, we put in the rudder, and you can keep the ailerons neutral. The aircraft will yaw because this outside wing, and just, if this was a disc, this side would have the same effect. Lift is increasing, there's a roll, the lift vector is now tilted, and there's a pitch down. Okay, so that's pretty normal. And as you go into the recovery now, is first of all, you've got to close the throttle. Why? Because you don't want to accelerate faster. After that, you must restore balanced flight. In other words, the yaw that you've put in must be neutralized. Ball in the center. And now, let's say we're there, and let's say that is the closest horizon there, and then we roll it level to the closest horizon, and we gently pitch it out so that we don't get a secondary stall. Well, I'm talking here about a secondary stall. Now remember, in the helicopter it will be slightly different, but in the helicopter the problem is now, look here, closing the throttle is not a possibility. Let's get some color into that. It's not a possibility. We can't. All right, so we must immediately restore balanced flight. Now, balanced flight would definitely mean that as you yaw the aircraft, whatever initiated the yaw, in this case, the full left yaw pedal, means that you've got to at least neutralize it. In other words, that which put you into the situation, get rid of that. Then roll the wings level to the horizon. That's the next one. And then pitch out of the dive. Why? Well, remember, this is going to take a lot of torque. The nose is low, speed is high, and if you really push it too hard, then you can actually get a main rotor RPM droop or a reduction in main rotor RPM. Good, just a little bit of just to show what I meant when you put on bank. Yeah, I've only got 45 degrees angle of bank here. On here, here's my little helicopter. I turn it around. Now, if you look at this drawing, you'll see that this is 1,000 kilogram. And if I was flying straight and level, it would have been there. But now remember, I tilted it. And if I don't do any increase in the pitch angles or the angles of attack, nothing else is going to happen. And the lift vector being still the same is going to be here. But now if we vectorize it, we'll see that there is a shortage. And how do you recover from that shortage? Well, as you can see up here, you've got to increase it with lift. All right, in our case, this is then the reason why the aircraft nose is pitching down. And if you don't do anything about it, and the problem is if you leave this for a while and there is a lot of momentum already created, just to get it out there. And you know, a lot of people think that once you're there, you can pull out of the dive with bank angle on. Remember, you're just using a phenomenon of torque. You're just making it very difficult to carry on with this. So let's now look at how the situation can be worsened. First of all, I say the more the forward speed, the more prominent the roll and the resultant in the yaw will be. All right, so forward speed must be low. And you'll see later on that we're going to talk about pirouettes and guppy turns and stuff like that. For now, for a normal turnabout, as in this case, there is going to be the problem of forward speed. High forward speed, not a good idea. All right, secondly, the harsher the yaw pedal input. And remember, in this case, it was a full input, so that was not a question of was it harsh or not. It was a very harsh maneuver during the input. Choppers don't like all these. It's not an aerobatic thing, all right? Especially not with the Robinson 22, Robinson 44, and most of the smaller aircraft. Well, even the big boys, they're not dedicated for this kind of maneuvering. Then, here I say normally that, you know, the pilot is sitting here, he's flying, and he's visualizing flying and doing a turnabout maneuver, facing in the dead. In other words, he wants to go 180 degrees about turn. In this case, what he would do is, as he is putting in the yaw, which results in a roll, but he also puts in cyclic, in other words bank, which further increases the roll and further actually contributes to the problems maintaining altitude at that stage. And then obviously to pull out from a spiral bank situation means considerably more pitch. The last one, and let me just get that eraser there, just going to get out of the space here, and we say that that which induced the situation in the first place. In other words, we're talking here about the yaw. If you don't recover that now, in this case, the helicopter was actually found with full left yaw pedal in. The pilot never reduced the input of the yaw. And therefore, it's like getting into an aircraft spin. If you maintain the yaw, the aircraft is continuing the spin. It is doing what it is supposed to do. It's basically all that I can say in this case. Right, then avoidance of the spiral situation. Well, the entry of a huge yaw moment in the hover. Well, you know, this is normally called a pirouette. Now let's just have a look at the pirouette. A pirouette, remember we're talking about a hover turn or a spot turn, which is around a position and a spot on the ground. But once you take another position, and the helicopter, sometimes you will see the helicopter does this around the turn here. This is what we call a pirouette around it. Now, a pirouette takes a lot of power, yaw, a lot of pitch down moment to be able to fly to the center and around the center as well. And the idea is not here to teach anybody about pirouettes. So be very careful before we start thinking, you know, we've got a pirouette going. Stay away from the pirouette. You need also, and I know that's not what it says in the sentence, but remember, you need experience. A turn through 180 degrees, call it a guppy turn. Now normally, in a situation, let's say flying at an air show, or maybe just advanced hover exercises, is where you've got forward speed. Now the forward speed is normally as little as between 5 and 10 knots. Maximum 18 knots because of the crosswind component limitations on the tail boom. Alright, just imagine trying to put at 40 knots, full yaw in. That means that the crosswind component here, all taken in consideration, is about 40 knots. Way outside the actual design. It's maybe not outside the design limitations with all the fudge factors that the manufacturers worked in, but it definitely is way outside the guarantee that the tail will stay on. So be very careful to be too rough. Remember, there are these moments. Okay, but a guppy turn, therefore, is the speed is low. And what you do is maintaining the direction and the momentum in one flow is to hover about this and do a turn while you are moving along the line. All right? In other words, if I can just show it in a different way, you come in, you turn around, and you turn around and show. So you're describing a line and you're hovering, but while you are doing hover turns, you are maintaining the direction and the momentum and the height over the ground. And everything is nice and balanced. All right, but that's a guppy turn, and this is not what we are required for the specific maneuver. A control of the yaw when turning momentum is picked up by Weathercock effect. Oh my goodness, it becomes. Now let's just look at this scenario. And remember, in a case, let's say we're flying towards me now, the wind is coming here from the front. The moment that you put that excessive yaw pedal in, so there the pedal goes, yaw pedal goes in, this is now the wind coming from this, and the wind is trying to stop from the weathercocking as the tail moves past, and the moment it gets here, the wind starts accelerating the turn. Alright, and then obviously as it gets into turn, it slows, into wind it slows down. But the acceleration part is there, and remember that's again where people start losing control of the helicopter. And then we've got the tight circuit. Tight circuit basically is when you are flying, it's normally set up about 150, 200 meters out, 150, 200 feet up, and let's say here's a bush, and here we're coming to fly in. Normally the speed is typically 40 knots, 50 knots maybe. And as you're coming right next to it, you see, oh my goodness, there's a buck, I need to get to that bush very quickly. You don't yaw the aircraft around to get there. You bank the aircraft and you do a steep turn to get here. Quite a different maneuver. All right, so this tight circuit, the basics of the circuit is normally taught, you know, especially in the beginning. But remember now, what you do at PPL stage, and later on you're going to try and use this in capturing game or in any other advanced maneuvering. You've got to brush up a little bit more on this, because this is it's not as easy as it sounds. Then we come up to the conclusion. So, what I say, a tight turn and a level yaw through 180 is not the same thing. All right? A tight turn is physically a turn and a pitch through and 180 to stop, and it's not a yawing around it. So, the gentleman in this case, well, he wasn't a trained game pilot, so why he tried this maneuver, I don't know. But you know, when we start just watching from the ground what people are doing, and you think this is what they do, and obviously, as you can see, the result, not very nice. Then the next one, a spiral situation is very possible in a helicopter. In fact, it's not just possible, it happens. Because you will get your yaw, you will get your roll, and you will get the nose pitch down. And it will be, and if you don't know how to recover, it's definitely going to leave you wanting, especially when the ground comes very close. I say that recovery from a spiral situation takes a few hundred feet. And to think that you can just, you know, stop this very quickly. You don't practice these things at low level. You don't. You must first of all know what you do. There must be a very good schooling, and then you ease into maneuvers on how to do them to see the helicopter responses. And you don't do that right close to the ground. It's just one of those things about training. Now, tight circuit, that is, it is not my idea now to talk about how do you actually maneuver the turnabout gear. There are various techniques as well, and we'll eventually get to those. But for now, remember, it is not a yaw about. It's a turnabout maneuver. Now, I'm talking here about a pirouette. Be very careful, because it is a very difficult maneuver. I write here, I say, it's an advanced maneuver normally used to show pilots and helicopter gunship pilots. The maneuver needs the correctly designed and powerful machines. You don't just whip it. You know, if I look at the Weathercock attack helicopter, sideways flight up to 60 knots, not a problem. You could really whip that one around, because sideways flights at 60 knots, actually quite possible, because the sort of tail section, because the body sort of blend into the tail section, but it's strengthened for that specific purpose. But in the R-44, this maneuver was never tested. Well, as our accident pilot tried, this maneuver was never tested at that speed by Robinson. That I can give you. Why not? Well, it's got to do with everything that we've explained here. That is not right, and the stresses and strains that it would put on the tail rotor. Well, at least on the tail rotor, on the whole tail section. Well, that brings me to the end of the review of technique. And the one thing that I can say, or if I can sum it up, is firstly to say, do not go and do maneuvers that you've seen somebody else doing without being taught on exactly how to do that. Because this is the result. You end up on the ground in a mangled heap, and then everybody says, I don't know what happened. Oh, we know what happened. We know that you were not trained. You knew you were not trained. Now, after seeing this video, if you go out there and you try to play cowboy, well, then don't cry. Because, you know, the world is actually, or aerodynamics is straightforward. If you show the right respect will be shown to you. Okay? But remember, flight safety is an attitude. Until next time.